If you've never worked as a professional software engineer, I don't think you're going to be successful in doing MLOps without at least having a little bit of experience working alongside a software development team. So I would say if somebody was interested in doing MLOps and they have never worked as a software engineer, that they should actually spend some time at learning from software engineers and watching what they're doing, because that's probably one of the best ways that you could learn MLOps is to first get DevOps. If you don't have DevOps, you don't have MLOps. It's one thing to create a model that works inside of a Jupyter Notebook. It's a very different scenario to actually take the model, put it into a production system, and then the production system uses the model to make decisions and solves business problems and creates revenue.
This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. Hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today our guest is Noah Gift. Noah has over 30 years of experience in the tech industry and he's currently an executive in residence at Duke Universities, where he teaches courses on MLOps, cloud architecture, and Rust for ML engineering. He's an award-winning author with best-selling books on DevOps, MLOps, data engineering, and cloud computing, and over his career, he has taught to thousands of students at various universities and to hundreds of thousands of students online. So very, very exciting career, and I'm super excited to have you on this show. First thing I want to ask Noah is, if we go back a bit, a couple of years ago, how did you actually get into this world of data science, AI, and tech industry? How did you get into the field?
Yeah, I would say I probably got into the field in an organic way, which may be a common pathway for many people, where I was starting my career in TV and film, and that was the genesis of a lot of, I would say, data engineering based workflows. And then organically, I went into startups, and then the natural thing to do was to do things with machine learning. And I think there are definitely some people who have followed a similar path. Maybe the alternate path that I've seen people do is they have been more of a PhD in statistics or computer science, and they've gone through that path. But the path I went through was more of just the natural trend of industry, and I followed it and just kept evolving.
So can we say a few words on your experience in the film industry? Like, when was this and how was it to deal with data at this time?
Yeah, I think the film industry is a very good industry for people that are currently in the data engineering and machine learning engineering space to look at. So I'll have to go back a little bit further in that when I was a teenager, I worked in Hollywood because my family had a very small television production company. And I was learning some of the things that you would do, like audio, video editing. And so I had some of those skills as a teenager. And then I was able to get a job editing live network television, national television when I was 18 years old, as basically like a summer job, which was kind of unusual actually to get a job like that. But that was really the start of my career, as I had a lot of experience in the analog equipment. But then when I went to college, and I actually had to make a choice, I was actually offered a full-time position at 18, and it would have been, I would say, a very interesting detour that I could have taken in my life to work in Hollywood, at that early. It probably would have worked out reasonably well, but I always wanted to, get educated. And so I went to college, and then after college, I worked at Caltech, which was like a hotbed of things happening with Unix and Linux, and during that period of time, after I spent a few years there, I decided to go back into TV and film because there's so much stuff happening in 2003 in TV and film where there was a transition of analog to digital. And so that transition meant that everything was now a file, and that you had to write automation to move those files all over the film studio and create automation scripts. So really, I would say 2000, the early 2000s were, I would say, the genesis of modern data engineering, because the film studios, if you look at Sony, Disney, Pixar, Weta Digital, they really had to invent new techniques, and they were using Python at the time because the workflows were IO bound. There wasn't really a requirement to use, let's say, C++ or to use Java. In fact, there were real limitations with that because you needed to move very quickly. So that really gave me a pretty good perspective of what we're doing currently, in that you oftentimes had to write some kind of automation that would take, maybe like a few hours to get some workflow done. I think the fun part of film is that a lot of times you have to work on things that are experiments, that you have to build something very quickly just for one particular day or for one particular week. And so there's actually, I would say it's like more fun in some sense than regular software engineering, because you don't really have any rules, and someone will come up to you that's creative, maybe like a director, and they say, like, we need to do this and this and this and this. And then you have to just write some code really quick and, get it done. The downside of the film industry is that it doesn't take much to look into some of the horror stories that, people have had with quality. There really has been a lack of software engineering best practices for decades. And the film industry has spent a lot of money building bad solutions. And I think it's getting a lot more mature now. And I think some of those things are gone, but there's been some just horrific code that I've seen in film. And I mean, I could talk for several hours about how bad the code was that I've seen in different organizations.
And concretely, was it more like ad hoc task of things to do in a couple of hours? Did you also have to create data pipelines, like ETL pipelines, to extract, load, transform data from one file to another format? Or what did you have to do there?
Yeah, so there's always a mixture of both. In more mature organizations where they had rigor, there was very formalized automation pipelines that would do exactly that. A lot of the film pipelines are around taking media files and transcoding them from one format to another, or applying some kind of transformation to them. And this is actually kind of interesting, is that you also send them to something called a render farm, where basically a whole host of machines will work on one frame at a time. And so some of the things that people are doing with like Spark and Hadoop, I mean, it's been done quite earlier than that, in that it's the same concept, is that you basically have a cluster which has the storage attached to it, and then you write a parallel job. So I think in the more mature organizations, they have a pretty formalized, automation pipeline set up. In some of the even places where there was some maturity, sometimes there's basically production engineering, which are more like software engineers, and then there's more artistic engineering, which is basically a Wild West. And so sometimes what happens is that the production software engineers are building, very solid solutions, doing software engineering best practices, or relative to film, software engineering best practices. But then there also will be people basically creating, like, I would say, like a nihilistic worldview, where they're just out for the day's work, and tomorrow anything could happen. And if they blow up the whole film studio, they don't care. And that's a very common attitude. And I've even had people tell me before things like, well, our department is the most important department. So if we shut down the film studio for several days doing really bad code because we locked up the database or whatever, it doesn't matter because we're more important.
Yeah, great mentality. I guess sometimes people are just focused on the short term and delivering impact, even though it's bad practices. They just want to get something up quickly. And so in the long term, that doesn't really work.
I think it's a mixture of like a lack of experience in terms of software engineering and also like a nihilistic attitude. And I don't know why the film industry attracts that style. I have not seen it in the other industries I've been in, academics or in startups or telecom companies. I mean, there's different problems, but there definitely seems to be this, I guess I would say like a willful ignorance in that people are okay with creating just catastrophically bad solutions that cost maybe millions of dollars in downtime. And and when you question them on it, it's like, why did you do this? It's like, because I could. I mean, there's no like logic. It's just, well, no one stopped me, so I just did it.
Yeah, interesting to have this view on what the film industry look like. And also when you think about data, I had never heard of someone working in the film industry, so quite interesting to get your view on that. You mentioned that after the film industry you moved to startups. Can you touch a bit on this experience? Why did you move? Why did you start working in startups? And then how did you move again from startup to teaching?
Yeah, so I think after I had spent about 10 years working at the top film studios in the world, all over the place. I worked in Disney, feature animation, Sony ImageWorks, and I had some very high-level positions too, where it was a very prestigious position where I was in charge of, the editorial pipeline and building the first feature animated pipelines. And then I worked in Turner Studios in Atlanta. Then I worked in New Zealand with Weta Digital. And so there was a lot of fun things about it. And then I worked at another film studio called, basically another Disney offshoot called Sony ImageWorks. And I would say the biggest reason that I changed was that I basically knew that there was not an emphasis on quality, and that it was just disappointing that I was just not interested in building bad software. And a lot of my career in the film industry was cleaning up very bad messes that other people created. And it just got tiresome. It was like, I don't want to do this anymore. I feel like I can do better things with my talent. So when I worked at startups, there's also problems with quality at startups, but relative to the film industry, as bad as startups can be, nothing matches the film industry. It's just the quality of software is just terrible. But startups is a different scenario in that you're now basically the center of attention, where in film, the director or the artist, they're kind of at the focus. And so they're the most important, part of the company. And I've even had film directors say things like, well, we're not a software company, kind of like making these excuses. But in a startup, you are a software company, so you're now the focus. And so I think that's one of the nice things about moving to a startup is that you really do have to actually focus on delivering. I would say the early experiences I had with startups were that I think now that I have some experience about it, is that they have a similar quality problem in that there's this focus on just trying out ideas and experimenting fast. And I think one of the things that I learned from startups is that the founders of the startups don't have all the answers. I think it's really common for people to assume that someone that started a company is very good at software engineering, or they really know what's happening. But in the Bay Area, I would say if you look at, let's say, 100 companies, 95 will fail. And it's actually designed that way. So you could almost think of it as, building like a cloud computing cluster where you spin up, a bunch of nodes to do some kind of work, like 95 nodes, and then they finish their task and then they die. And then there's only 5 nodes left. So the purpose of startups really is to fail. So I think that was not something I was fully aware of, was that basically, majority of people in their career will work for failed companies their entire startup career because the 95% fail. And so if things don't make sense, it isn't that you're doing something necessarily wrong. It's that the company was designed to fail from the beginning because they're doing very risky things, writing risky software, taking risky business decisions. And I think that's probably the biggest takeaway I got out of startups, was that even if you do everything perfect, write amazing code, create millions of dollars in revenue, all things I was a part of, it doesn't matter, because really your purpose is to fail so that the venture capitalists can succeed. So I think that's probably the big wake up call that a lot of people probably need in the Bay Area, in particular, is to think about the fact that a startup almost is like going to school, that you're paying because you're making less money and you're taking all the risk, and you're paying, the venture capitalists to learn something and hopefully you learn something before you then go somewhere and actually make some real money. And then afterwards, after I had, another decade working at startups, I had gone to school part-time, getting a full-time master's degree in business at the University of California. And so I had enough kind of academic credentials that I had a professor reach out to me and wanted me to teach machine learning in their new data science program. And then I started teaching and consulting. And then since about, I would say 2017 or so about last 6 years, I've just been teaching, consulting, and creating content full time.
Okay, great. So to summarize, you worked in the film industry for around a decade, and then you moved to the startup world. You learned a lot, but also failed and learned a lot, but didn't enjoy it so much. So you decided to move to the teaching field, and you've taught, as I mentioned, lots of things, courses around MLOps, cloud architecture, and much more. I want to dive a bit into MLOps because it's a very, very popular topic nowadays, especially, in industry where I'm working at the moment. So before we dive into the details, just an intro. What is MLOps for people who aren't familiar with the field? And how did you get into MLOps? How did you start learning about it?
Yeah, so MLOps is I would say, operationalizing models. So it would be, I would call it a branch of DevOps. And so one of the things I like to say about MLOps is that if you don't have DevOps, you don't have MLOps. So I think a lot of people coming from statistics, data science, have no formal software engineering background. Mm-hmm. And so when you mention let's do MLOps, I think they are missing a big component, right? That if you have never made a web service deploy automatically with testing and continuous integration and continuous delivery, then how could you possibly make a model get deployed automatically? So I think that's probably the biggest misconception that people have, is that they I think maybe lack the experience to know what they don't know. And that if you've never worked as a professional software engineer, I don't think you're going to be successful in doing MLOps without at least having a little bit of experience working alongside a software development team. So I would say if somebody was interested in doing MLOps and they have never worked as a software engineer, that they should actually spend some time at learning from software engineers and watching what they're doing, because that's probably one of the best ways that you could learn MLOps is to first get DevOps. If you don't have DevOps, you don't have MLOps. And then really it's just a branch of DevOps, which is that you do all the things that you're doing for software engineering, but now there's a new component, which is a model. And then you do some similar things, like you have to actually make sure that when you put the model into production, you know if it works or not. You have observability so that you know that the accuracy is there. I think there's a lot of misconceptions that it's basically all data science when it's very little data science in terms of MLOps, because the 80% of the problem really is just DevOps.
So it's kind of a combination of machine learning and DevOps. You mentioned some examples like putting model in production, monitoring the models, making sure that they are deployed well, that their performance doesn't degrade. Before we dive a bit into more practical examples, I'm interested in the software engineering component. So you said you first need to learn or work with software engineers. Why is it important for data scientists to know about software engineering? And is it even important? I think many data scientists think they don't really need to learn all those software engineering practices. So what's your take on this?
Yeah, I mean, I think it's the difference between making an experiment or prototype or putting a product into a store, right? Like, either your product is in Target or Walmart or some store, or it's not. It's that simple. Like, if you can't produce the product at scale, then you've created an experiment. Similarly with data science, it's one thing to create a model that works inside of a Jupyter notebook. It's a very different scenario to actually take the model, put it into a production system, and then the production system uses the model to make decisions, increases, elasticity, increases the retention of customers and solves business problems and creates revenue. So it's really that you need to actually understand what software engineering is and have experience, not software engineering in the academic sense where you learn algorithms, but software engineering in the practical sense where it is actually a production system that creates revenue and it's running 24/7 and people are on call. So I think that's probably the biggest misconception, is that the things that people are doing currently are not relevant, when in fact they are relevant. It's the opposite, is that the majority of the relevance is in building production systems, and a very minor component is actually the data science.
Yeah, no, definitely agree. In industry, there is some value in playing around with a notebook and analyzing data. You obviously need to do that. But then if you really want to have a big impact, very, very often you will need to deploy a model in production. And that's the MLOps part of things. And that's why I guess it's becoming so popular today. It's not enough to do some experiment in a notebook, because if you cannot deploy your model in production, well, you're not going to have a very big impact.
Yeah, I mean, if people can't use the thing you created, then the value is very little.
So we talked about software engineering. What are the software engineering skills that data scientists and machine learning engineers need to learn in order to become good at MLOps and in order to be able to deploy ML models?
I would say that maybe 2 or 3 main areas. One is continuous integration. So I think many data scientists don't know what continuous integration is. Fortunately, it's pretty easy to learn, which is that you want to automatically test your software and make sure that it's always in a known good condition. So that's a hard requirement, especially for languages like Python, which are scripting languages that if you're using a compiled language, then at least the compiler will not compile the software. So, it will break. In Python, it's very likely that your code just doesn't work. And so if you're pushing code that doesn't work, then you push that into production, then your whole system goes down, right? So you need to be able to automatically test your software and understand that component of it. Another one is the making your infrastructure idempotent so that you are able to deploy infrastructure changes that don't take down production. So it's not enough just to have your code work locally. You also need to, in the cloud environment, have a provisioned amount of servers and have it configured in a way that it can move up and down. And so you need to understand infrastructure as code, which is basically writing code that manages your infrastructure. And then I would say a third component would be you need to understand monitoring and observability. So this one is a little easier, I think, for a data scientist to understand, in that, what is monitoring and observability? Well, it's data science for software engineering. So, why would you use data science to make decisions like on vaccines or something? Well, because, either you're basically a barbarian who doesn't understand how the world works and makes decisions based on, really weird ideas about what is effective and what isn't, and you listen to strange news sources, or you just look at the data, right? You look at the data and say, well, what is effective? How do I live a healthy life, right? That's data science, right? Making decisions based on data. Similarly, if you just push code out into production and you don't know if it works or not, that's similar. It's like a barbarian, right? You're like you're not really using science to make decisions. But a good software engineer, when they push something into production, they know what will work. They know like descriptive statistics about the latency of servers, the amount of errors that are occurring. And so, just like with a data science problem, the more observability you have, the more scatter plots, the more information you have, the better you understand the nuances of the problem. You have to apply that data science to the deployed software.
Yeah, I definitely agree with all the points, but especially the last one on monitoring. And that's maybe what makes, I think, MLOps even more difficult than software engineering and DevOps, is that in machine learning, data is changing all the time. And so your problem is changing all the time. And so a model that performs well today might not perform well in a week or in a month or in a year. And so if you don't monitor this model, things very bad might happen, because your model might perform very well today, but very badly in a couple of years. And usually in software, it's a bit more static, although not always. But if you push a code and it works, you can be quite confident that it's going to work tomorrow and in the next few days, although it's not always the case. But in machine learning, the world changes all the time, and that brings a quite difficult additional component, I think.
Yeah, I mean, I think the best way that I like to describe it is that it is data science, but with a specific domain of software engineering. And if you're a data scientist of any type of person, you should understand why we should look at data.
So just to make it even clearer, first of all, very keen to get your view on why is this field becoming so popular. I think we've discussed a bit of the impact of deploying model, but why do you think it's so popular nowadays? And also, can you give maybe one or two practical examples on how MLOps is actually used today in a company?
Yeah, so I think in terms of popularity, it's popular because people are realizing you can solve real problems. Like, I think predicting things with accuracy is a great example. That's stuff I've had experience with. If you're able to create a prediction model, you can make decisions that really save you money, right? Like if in my particular case, we created prediction models that we're able to figure out who we should partner with in terms of influencer marketing, and we didn't have to buy advertising, and we grew to millions of users. Similarly, there's new domains like generative AI, where people are realizing that it can solve real problems like make you more productive and writing software. So I think that's why it's popular, is it's useful. Real world examples of MLOps. So I would say the chatbots that have been deployed, I think, are pretty good examples of real world MLOps, in that they train a model, the model was useful, they deployed it, it solved real problems, and they're able to deploy new versions of the models that, in theory, will get better and better we've seen this with OpenAI. They've deployed new models that got better and better. So I would say that those would be the components of what MLOps are to me, is that you created something useful, you deployed it and maintained it, and were able to improve it.
Okay, so very clear. Hopefully the listeners are now kind of familiar. So let's dive a bit more into the details. I don't know if we can really call these subfields, but what are like the subfields of MLOps that you're particularly interested in? And maybe we can dive into one or two. I know you've taught some courses on Rust. I know you're also interested in LLMOps, but yeah, what are the subfields that you're interested in? And yeah, let's dive into one or two.
Yeah, I think there are people talking about large language models as a separate component of MLOps. I think it's like a coin toss. I mean, you could call it MLOps, you could call it LLMOps. I would even say you could call all of it DevOps, right? It's just, so you could say that anything where you're deploying software automatically is basically DevOps. But in the case of LLMOps, I think the big difference is that in a maybe more MLOps workflow, you may have trained the model yourself, but I think what we're seeing is that there's lots of use cases where maybe you don't do anything. You just take a model and you deploy it into production that somebody else created. I'm pretty sure we're going to see a lot of this in the future. So, you could call that LLMOps if you wanted to. And where I see there being some changes are that if it's the case that you're going to deploy models that other people built into production, then really do you need some of the tools that we've used previously? So I think Python is valuable for notebooks. If you're doing ad hoc data analysis, it's pretty tough to beat. I mean, Python is very good, right? I call this the 4 stages of data science: ingestion, exploratory data analysis, modeling, and conclusion. So like if you're building some kind of report for a company, you do those 4 stages and you maybe keep it in a notebook. But when you do LLMOps, none of that matters. None of those components are actually valuable anymore. So the notebook has, in my opinion, no value in LLMOps, or maybe 1% of the value. So I actually find it strange that people are using notebooks with LLMs. I don't get it. I don't get why they're doing this. What I find is much more valuable is the most performant language you can find. And in the case of Rust, it's definitely one of the top languages in terms of performance. And because it's a modern language, it actually has a lot of advantages over previous high performance languages like C++ or C. And one of the ones is that, you don't have to manage memory. So in C++, that's actually one of the big barriers to entry, is that many people are afraid of having to manage memory for a good reason, because it's very complex. In the case of Rust, because they use this concept of ownership where you declare a variable and then as soon as you don't use it, it goes out of scope. That's it. You don't have to actually do any kind of memory management. So it's a pretty actually reasonable heuristic to get rid of memory management. And also the verbosity is not too bad. It's a little bit more verbose than Python. And then also because we have generative AI tools, they can help you write Rust code. So I find that Rust with LLMs is actually very good story. And so whenever you're solving a problem, you should pick the right tool for the job. And I feel like LLMs, Rust is the right tool. And there's some emerging frameworks, like the one that I'm very interested in is by Hugging Face. It's called Candle. And you just run one line. So unlike Python, actually is much more complex. Python, if you want to run a large language model, there's just lots of hoops to jump through because of like virtual environments, which I find to be a solution in search of a problem. But with Rust, there's just one line. You just say cargo run, and then you have a binary that you can run, or you can even just build the binary and then push it somewhere else. So I think this is going to be a very big story, is that people are going to just treat the large language model as a component of a software system, just like you would treat a database or you would treat like, static files or some other aspect of software engineering. And so if that's the case, then some of the things that were important previously in traditional MLOps just go away. So if that's the case, then it's even further a software engineering problem.
Okay, very interesting. I'm not that familiar with Rust, but what are the pros and cons of using Rust rather than Python?
Well, I think one of them is that by default, you get binaries. So Python doesn't have the concept of binaries. So if you want to share some code with grandpa, grandma in Python, you would think it would be easy actually, but it's very difficult to share code with grandpa, grandma because they don't know what Conda is. In fact, if they had to install Conda, it could be weeks. They could destroy Conda could destroy their entire machine. I've had students where I'm teaching something and then I look over and say, why is this not working for you? And they say, yeah, like I have this thing called Conda. It's like, oh no. It's basically like a virus and they don't even know how to get rid of it. It's just all over their machine. And I think because you need virtual environments to install third-party packages, that's basically you're dead in the water. Like I think Python should actually delete all virtual environments permanently from the ecosystem and do a directory-based packaging system. And then you actually could share your code with grandpa, grandma. So basically the packaging and the binary deployment is something that Rust has that's really exceptional. The other one is that the performance is basically C-level performance. So what it means in practice is that Python can be 70 to 100 times more memory and CPU than like a traditional Rust program. And so this can really be a big issue in terms of if the verbosity of the code is about the same, but you can get 100 times better performance. I mean, that's the median. There's cases where you can get 1,000 times better performance. That what that means is that at scale, you could have a system that's doing inference, for example, that is costing $100,000 per month. If it was pure inference and the Python was talking down to C, maybe that wouldn't be the case. But it's never the case that your code is only doing this one thing. You're going to have other bits of code that are slow. And so let's just say you have a system that includes some inference and it also does calls to the database and does some other things, that you could have one solution that costs $100,000 per month, and you could run this exact same solution for 1,000 in Rust. So to me, that's significant, right? Like if you could save 100 times the cost. So I think those are probably the two top cases for Rust versus Python. The third is that actually security, by the design of the language, is much more secure than a lot of other languages because it's been a modern language that was able to learn a lot of things like the memory safety, for example. That's a classic problem with C++, is buffer overflow, all these memory allocation problems, and also threading as well. The compiler itself, many race condition scenarios, not all of them, but many of them just get solved via the compiler. So, I think if you look at those three solutions, the packaging and binary deploy, the performance characteristics, and then the security, I think it really does make the case for at scale, if you're writing backend services or you're doing ML engineering, I think you should have a really good reason to use a language like Python. Python, again, is good for prototyping. It's like English, like you can go all over the world and speak English. Similarly, like you can go to any vendor and look at an API in Python, but it doesn't necessarily mean that you need to use Python for everything. The way I like to describe it is that, like, rosemary is amazing. Like, who doesn't like rosemary? Like, you put it on an omelet or some potatoes or some chicken, but you don't just take a bush of rosemary and just bite it. Like it's a spice that you're adding to enhance the flavor. I think many people are biting into Python and eating it as a meal when it should be a spice.
So I can share my experience as a data scientist on GenAI, and I like Python for prototyping because, well, you can use libraries like LangChain, for example, and very quickly, first of all, you can do a lot of things with LangChain, lots of chains, lots of different LLMs, lots of different use cases. And in a notebook, you quickly get like a solution, or you quickly see whether your model is going to work or not. So that's what I like about notebooks. Usually I would start like the experiment and all of this in a notebook, and then I will work towards deploying this and towards developing an app. Would it be possible, and what's your take on prototyping in Python, having a notebook to quickly check whether your LLM is going to work, and then moving to Rust? Can you do that, or because the two languages are different, that's not going to be compatible? And I'm mentioning this because from what I understand, you don't have notebooks with Rust. So I'm just thinking about a way to combine the two.
Yeah, I mean there are actually notebooks with Rust. You can run Rust in Jupyter Notebook, believe it or not. Mm-hmm. So you just have to look for Rust Jupyter Notebook. But yeah, I think that's okay. Sure, why not? I mean, if it's just a tool, like so if you're doing some stuff and it seems like it's a fit for Jupyter Notebook, yeah, why not? Just you're using yet another tool to help you out. Yeah, I think when you get to the model though, then that's where I think Python really is lacking, is that the deployment story is very poor because of the virtual environments, and also that you're even in many cases having to use like third-party packaging. Mm-hmm. It's the strangest thing in the world. I've never seen something like this before, where there's some company that actually owns the repositories for open source code. It's the weirdest thing in the world. And then they like shook down all these big companies and charged them licensing fees in the case of Anaconda, and then later changed it. And then, the whole thing just is like not interesting. Like to me, it just doesn't sound like a good ecosystem to invest in. I would much rather go to something that's just free. Like I don't have to, if I use Cargo, there's nothing to do. I just say Cargo build, and then I get a binary that has the model inside of it. So I think the deployment story is much simpler. Also with Python, the concept of Docker in many ways saved Python. Like if Docker wouldn't have been invented, would we even be using it for web services? Probably not, because Docker rescues Python deployment because you can package it all together. Mm-hmm. The problem, though, is that many of the same issues still exist with Python. The performance is terrible. Also, the size of the Docker image that's created is just gigantic. I mean, it's very possible that you could do something in Python and easily get a 4 gig Docker image. Right. And you're like, what is this? and like, you don't even know what's inside of there. The exact same functionality in Rust could be like 10 megabytes. And you're like, what am I doing? Because you don't, even if you use Docker with Rust, if you use like distroless, it would shrink it quite a bit. But you don't need Docker. Mm-hmm. You don't need containers if you have a binary. And I think Docker is interesting, but in many scenarios, you just don't even need it. And for production software in Go or Rust in particular, those two modern compiled languages, I think the binary-based deploy is very elegant. And the less tools you have, the less likelihood something will break.
Well, summary of this conversation, I should go and learn Rust just as once we finish recording. But yeah, I get your main point that Python, you think that Python should be used as a tool and not like for everything. There are some great things about Python and we should continue to use it, but we shouldn't use it for everything.
Yeah, I think it's just lazy. I mean, not that I have not been lazy in lots of different things in life, but the thing that is very tempting is that because you know something, that's the technology you choose for every single scenario. Like if you knew AWS and that you're working at a company that uses, I don't know, Google Cloud, and then you say, well, I can't do anything. We got to switch the whole company to AWS. Well, that's probably not going to work, right? The company will say no. Similarly, just because you know Python, it doesn't mean you should use it for every problem. I think to be totally honest, if you want to separate somebody who's mediocre or average with somebody who's exceptional, is that exceptional people keep adding new skills and challenge themselves and constantly adapt. If you're mediocre, you just do what you've always known. So if you only know Python and that's the only tool you have for every single problem, then you're not going to be as impactful as someone who says, maybe rightfully, let's say if I want to use notebooks for data science, Python's the right tool. So if someone was only a Rust programmer, then they would be lacking, right? They would have missing skills because the Python programmer could run circles around them because they know notebooks and data science. On the flip side, if you're only using Python and you did all this awesome stuff with Jupyter Notebook, but then it's time to go to production, and you say, well, because I know Python, we'll just use Python, and you're spending 100 times more money than you should because you're not doing it in Rust or Go, for example, then you're basically delivering below average results. So I think it's a harsh reality that you learn as you get older, is that there is no silver bullet, that you're constantly going to need to adapt and learn new things. And just because you're comfortable with a particular technology doesn't mean you should always use that technology. In fact, that's the lazy thing to do. It's just that, I mean, if you want to ask someone who, will give you bad advice, basically ask them all their own life experiences and all the tools that they've used. Say, did everything you do, was it perfect? And, that's what a lazy answer will be, is like, well, whatever I did was perfect, because nothing in the future will ever surpass what I did in the past. Like, that's just not true, right? Like we need to learn new things and have new approaches and have a mixture of different tools. In fact, technology, that's really the essence of people who are great at technology, is that every 6 months you're learning a new thing.
Yeah, as a data scientist or ML engineers, I fully agree with you that learning new tools is really the key to progress. And I'm now working actually in consulting and AI consulting. And one thing that I really like is you've got lots of different projects. And so you're trying lots of different tools, because one day you're going to work on Gen AI, deploying something on GCP, but the other day you're working on computer vision, deploying on Azure or another platform. So you're really, for every project, you're trying different tools, and that's such a great way to learn things. And definitely agree with you that if you keep using the same tools all the time, you're not really going to progress. Look now with Gen AI, people who aren't using Gen AI are going to lag behind, and people need to use it. And you need to, this field is evolving so much that if you don't try new tools, you're just not going to progress fast enough.
Yeah, we've seen this for decades. I've definitely seen it in my career where there's lots of people that got left behind, because it's like you're running a marathon, which, I've run several marathons. So it's kind of a similar example where you're running a marathon. There's some people that maybe they're even running fast at the beginning, and then they blow themselves up. And it's like 7 miles in, and that's it. They're done. Right? And then there's the people that finish are just consistent, right? They're consistently running. They're consistently going through all the different parts of the course. Similarly with your career, like if you started off as a sysadmin, that's a very common one too. People used to be systems administrators, and they would do certain things with physical data centers. And then a lot of those skills got converted to cloud computing. And there's a whole group of people who just never adapted. And they basically got left behind. And then, same with people that maybe only knew Perl, and then Python came out, like those people got left behind. Nobody uses Perl anymore. It's just a constant churn. Or data science. Like if you're only doing data science in Jupyter, and then, like you said, you just ignore LLMs and Gen AI, you're just going to be left behind.
So maybe one last question on MLOps. Actually, two last questions. The first one is, what's, according to you, what are the differences between LLMOps and MLOps, except the fact that you don't really train the model yourself at the moment? Let's see how it changes. What are the other differences that you see in both fields?
Yeah, I would say that the biggest difference is that, LLM ops is less less data science than maybe like traditional MLOps, and that some of the things won't matter. So, for example, the model registry or maybe the data drift or some of these just don't matter because you're taking a model that the world has already validated and you're just putting the model into a software engineering inference system. The complexity potentially could be in that if it's a big enough model, you're going to need to use specialized hardware. So it could be, very, very powerful GPUs. And in some cases, GPUs that are maybe even like multi-core GPUs where, you are, doing some kind of fancy inference. So I think it's really the LLM ops gets rid of certain things. So like, again, the data drift, the model registry, the training, infrastructure. So I would say it's in many cases much simpler. But then some of the more complex parts would be, picking the right language. In the case, I would say Rust would be a great one, but also the hardware. So where are you going to deploy it? Now, one of the differences too, I think that's going to be emerging is that a lot of companies are trying to sell very specialized services for MLOps, and those services may add no value with LLM ops. So, for example, I think SageMaker to me is a very complex service that, in some cases, there's some good things you can do with it, but in the case of LLM ops, I don't really see SageMaker even having a role. Like, what does it even do? Like, why would I want a notebook for LLM ops? All I care about is I need a machine that has a GPU. So why do I want all this other stuff? And I think that could be one of the big things is that if you're able to simplify the deployment story, and there's lots of different scenarios where you could use AWS technology. Like, for example, you could build the binary with Candle and then put the binary in, let's say, EFS, the managed file system, and then you could have AWS Batch actually do inference on it, right? So it could spin up a GPU, and then that would be much, much cheaper because you could run spot instances and you wouldn't pay for these extra services. So I think you can be very cost effective with LLM ops as well. So I would say LLM ops is essentially very close to most traditional advanced software engineering workflows, and that's probably the biggest difference.
Yeah, one thing that I think is more difficult with LLMOps is the performance of your models. Like, because and I mean, obviously you cannot, if you're using a third-party model, you're not going to change the model, but you can change the prompt often that you're passing to this model. It's sometimes quite difficult to evaluate whether one prompt is better than the other. And I think validation is quite a difficult topic that, still has to be solved. It's very new, but is my model now better than the previous model, or is it worse? It's kind of it can be subjective when your task is to write a report, for example. So I think that's another thing that's gonna come, and a problem that needs to be solved.
Yeah, I think that's true, that there's some ambiguity for what is good when you have these large language models. On the flip side, I would say there's a lot of opportunity because the idea that you call an API and you give some API all of your data, it seems like a very bad idea for many organizations. So I know the current leader is OpenAI, and they've obviously done some tremendous work, but does that really make sense that you would start giving OpenAI and / Microsoft your company's financial data, medical records, all these really sensitive documents where they even could be a competitor? And to my knowledge, there's no terms of service that says we won't use the data to compete against you. you would be very foolish to be sending OpenAI your data via an API. So in many scenarios, there's no choice but to run your own large language models. So I feel like we're at the very beginning stages of LLMOps as well, and that any large company should be thinking about less about like, let me call an API and try to do something with an API, but more like, what is our strategy to run models ourselves where we are able to control what's going on?
Yeah, no, definitely agree. And I think the field, at the moment, it's quite difficult to train your own model, but I'm sure it's just going to become easier and easier. And hopefully that's where the future is going. Just one last question on MLOps, and then we'll move on to a few questions on your career. If I'm a beginner who want to get into MLOps, or if I'm already into MLOps, but I want to progress, you've written book, you've taught classes. So what are the resources or things I can do if I want to level up my MLOps skills?
I think there's no substitute for just creating a portfolio or real services. So, create some GitHub projects that show that you can take a model and then put it into production. Even try out other companies, vendors, MLOps platforms. Like I think Databricks has a platform for MLOps, Azure has a platform for MLOps, GCP has a platform for MLOps. Try using these platforms. Maybe also get certified, like Google ML certification, AWS ML certification. I would say those three things is just build portfolios, also use the vendors that have MLOps solutions, and then get a certification.
Great. Thanks for this. So let's close the MLOps chapter and let's ask a few questions about your career before we finish the episode. The first one is, you've been in the field for 30 years, something like that. So I'm curious to have your view on what has changed over the past 30 years. What are the biggest changes, and where do you see the field of MLOps and AI going in the future?
Yeah, I would say the biggest stuff I've seen is that everything changes constantly. So every 6 months, and that people that don't change are not, like we talked about earlier, are going to be left behind. So that's the biggest lesson I would say, is that you need to have new skills every 6 months. If you can't do that, then maybe pick a different career. Where I see things headed is, I think there will be a retraction in the tech industry in terms of the startup world. I think there was maybe too many startups that were funded, and I think we're eventually going to get to the point where a lot of the startups, even that were able to go public, we're going to realize that they're not even profitable. Like I think Uber, it's possible they never become profitable. And we can see that companies like Airbnb, there's a lot of legislation now that's kind of coming after Airbnb because of the negative externalities, where homelessness goes up when Airbnb comes into a city, and they're getting rid of short-term rentals. So I that's what I see as a new trend, is that the startup itself, I know a lot of the venture capitalists are still really pumping all the startups, but I think there could be significant pushback against the startups, and that there could be a lot less startups. And I honestly think the world is probably a better place the less startups there are. I find it to be very mixed results, and I would even say that I would be very hard pressed to find many examples of startups that were helpful to humanity. So I think instead, there's potentially going to be a lot more expansion in non-pure technology companies, like the government, healthcare, manufacturing. So that's where I see potentially a lot of the changes. And if you look at the crypto industry, for example, that's a pretty good example of potentially, a good example of basically a full dud, where there's all these promises made and just absolutely every single thing that was ever promised and all the billions and billions of dollars that went into it, complete failure. Like the biggest failure of any technology section, maybe in the history of the last 30, 40 years. And so the same people that are pushing that stuff are pushing some of the solutions with generative AI or some of these new startups. So I think people should be very skeptical about venture capital funded companies. They should be skeptical of the people involved. They should be skeptical of the promises made. I call it a divide by factor. So, if you look at any famous person like Elon Musk, you have to figure out, what do you divide by? Do you divide by 10? Do you divide by 20? Like he says, hey, self-driving cars will be here next year. Well, we should at least divide by 10, correct? Because I think it's been at least 10 years. So maybe we divide by 15 with Elon Musk. Same with Zuckerberg. We're going to connect everybody, solve world peace or whatever. Well, you connected a lot of people and also caused a lot of harm throughout the world, including credible examples of genocide. In the case of Myanmar, right? Amnesty International has said that they're basically were propagating messages that caused a lot of harm. So I think there's a lot of promises made from the tech companies that turn out to just be completely false. Or in the case of FTX, I'm making all this money so that I can solve certain problems in the world through effective altruism. Completely a scam, completely false, just stealing money from people. So I think the skepticism of the tech people and dividing by a certain number, like divide by 10, divide by 15, like we're going to go to Mars. Probably not going to go to Mars. Is generative AI going to turn into AGI? Probably not. Right. Like, I think that's the biggest lesson I would say that people should have, is that deep, deep, deep skepticism of promises that people make. And sure, technology like generative AI is useful, like in generating code, for example. But I think if you have deep skepticism, you're going to have a much better career than blind optimism.
Really, I would tend to be more on the optimistic side. I mean, your view is quite interesting. I think with Gen AI, we might not reach AGI, but I think it's going to enable a lot. And I think it's going to allow a lot of people to actually build their startup, because with Gen AI, you can now create things very easily and very quickly. So I kind of see more startups in this space, or even more people going freelance, because it's just going to be much easier with Gen AI to build. Well, you can ask ChatGPT to write code for you. You can ask so many things. Knowledge is accessible very easily, easier than ever. And so, yeah, I kind of think more people are going to build startups, are going to build things. And I mean, I kind of hope this is going to be the way. Otherwise, it means Google and all those big techs are going to become bigger, better. And yeah, I think you have a pessimistic view of the world. Is that how you're usually?
No, I mean, I would. There's lots of things I'm optimistic about. I'm just more pessimistic that technology companies are going to do anything useful. I would say you could definitely make the case that very little of what's been produced is helpful to humanity. Very little. Some are like maybe iPhone, could be useful. There's some things that are helpful, like electric cars. There's some things, but I think a different way to put it is that the vast majority of what's produced is just junk, just absolute junk that's useless. Just look at by definition, right? If 95% of startups fail that are venture capital funded, then by design, the majority is junk, right? So I think, not that I don't think that there'll be advances, like, in the case of the TV industry, things were analog and then they went to digital, and I can do things on my laptop that took, hundreds of thousands of dollars. So there's changes. But if you look at the magnitude of what's produced, how big of a deal really is it? Like, I would say it's useful. It's like it's a useful tool, but it is nothing even close to what people have promised. That's more what I'm saying is that same with generative AI. Sure, I think generative AI will be useful. There'll be, people can do summarizations and maybe ask certain questions about books and help with writing code. But is it going to be even close to anything people are saying no? And even there's a scenario where governments also step in to even big tech, and they actually really legislate big tech, even companies like Google, Microsoft, Meta, and they actually break them up. So there's lots of things in the future that can happen where technology could be a very minor role. So I think there's an article recently published by Andreessen where he said, I'm a techno optimist. And I would say, like, in this case, consider the source. I think Andreessen in particular has been one of the biggest advocates of crypto. And that was just a complete dud. Every single thing he said was wrong. And in fact, many people were hurt very bad and lost billions and billions of dollars through fraud. So I think it's more of the skepticism of in particular, American capitalism from 1930 to 2030, or we're about to get to 2030, has really benefited the CEO, right? Where it used to be 50 times the median pay was to the CEO. Now there's many cases where the Microsoft CEO gets 2,500 times the median salary, or the Google CEO gets paid 2,500 times. So I think it's more likely what's happening is basically an increase in income inequality. And if you look at California, it contains 30% of all the homeless in the United States, and that there's homeless people, just miles and miles and miles of people in tents. You go anywhere else in the world. I've been all over the world: Germany, Dubai, China, New Zealand, Australia, Portugal, France. You do not see homeless people like this. So this is a creation of American capitalism. So I think the skepticism people should be very severe, in that there's something systemically wrong with technology in the United States in particular. If the technology was created in a different way, like if it was created in the case of Wikipedia, that's a great example of something that is unambiguously good, right? Like nothing that Wikipedia does, in my opinion, is bad. Like almost everything they do is helpful to humanity. It's a curated, source of information. So there's lots of good examples of technology, but basically the incentives of American capitalism, especially the venture capital component of it, to me, I think have really not panned out. I don't think it's really panned out. It doesn't mean that in the future things couldn't change, but I think people should be deeply skeptical because hopefully machine learning engineers believe in data science. And if you look at the data science and you look at the income inequality in America, and you look at the things that have been created and the negative externalities that have been pushed, onto people, you just look at the data. Like, show me the evidence that technology has been helpful in America in the last 50 years. Show me the specific things that have improved people's lives or solved humanity. I'll be waiting for quite some time, because there's very little evidence that many of the things that people worked on have been helpful. There's some, but very little that, versus the majority, I think, has been very negative.
And I think one goal of AI stories is really to get the views of different people coming from different backgrounds. And so I think your tech view is super interesting, and good to have many people working in tech are maybe more on the optimistic side, like everything is going to go, AGI is going to succeed, everything is going to progress. And so it's great to see how different people think about it. Looking back at your career again, I'm curious about, you've been in the field for 30 years. What's the biggest mistake that you've made?
I would say the biggest mistake I made was only hiring for talent. So I think it's easy to think that you should just only hire the smartest people that you can, but in practice, that has not worked out. And that, if I had to go back in time and hire people, I would say I would definitely focus more on the diversity of the team. And as I got older, I learned more and more, and I did this. But I would say the biggest mistakes I've made are just focusing only on like software engineering skills. Really, you want a mixture of talent, but also the ability to learn, the ability to work with other people, and the ability to work as a team. I think that's the thing I would say that is my advice is if you're building a company, you need to actually have a balance when you're building a team.
So let's finish the episode with just one advice. If you had one advice for someone to progress in their career, what would it be?
I think you should create a schedule where you actually build a learning program that you yourself, are the person who's benefiting from it. So basically, almost like a personal trainer. If you went to a gym, they would give you certain workouts, and you would do these things to improve yourself. That for your tech career, you should have an agenda for, what are you going to learn this week? What are you going to learn this month? What are you going to learn this 3 months? What are you going to learn this year? What are you going to learn the next 2 years? And you actually have to just continuously go through that agenda and learn those things. I think if you do that, you'll have a very good tech career. If you do not intentionally create a schedule where you're learning things, you're not going to be successful.
Well, Noah, thanks so much for sharing all those tips, all your views, all this experience. It was great to learn from you and learn from your career. Have a great day in the US, and hope to catch up very soon.